Hey learners, Jared here, and today we're going to walk through looking at video analysis of our pivot activity, the momentum and energy ratios during a collision. And we're looking at the video where we have these hoop springs here on either side of our carts. Now, this frame right here, I've got my ruler set so that each cart is essentially at a position 0. And so I've reset my time frame to also be 0. Now, if I go down to the next screenshot I've got here, it moves 31 frames, and the cart over here, our right cart, is all the way over at the 7 centimeter mark right there. And it did that in the 0.2583 seconds. So the velocity of my right cart, because it is going to the left, I'm going to make that velocity negative. And it's negative that distance, so 7 centimeters, 0.07 meters, over my time, 0.2583 seconds. So if I crunch that number real quick, 0.2583, I get a velocity of my right cart being 0.271, and that would be meters per second. Now, again, it's negative because that velocity is to our left. Now, the velocity of my left cart, which is going right, so that is going to be a positive velocity, it has only gone 1, 2, 3 centimeters, 0.03 meters, in the same amount of time. And so if I crunch those numbers for our left cart, 0.03 divided by 0.2583, I get a velocity of, let's go, 0.116 meters per second. Now, again, that is positive. So clearly our right cart is moving faster than our left cart. It covered more ground in the same amount of time. And the reason we can do this velocity is just distance over time is because our velocity is constant, meaning it's a constant rate of distance per unit time. And so just any distance over any time is going to give you the same value. And we can do that because we're on a nearly frictionless system. Now, once I've got each velocity, figuring out the initial kinetic energy for our system, it is the kinetic energy initially of our left cart plus the initial kinetic energy of our right cart. And it doesn't matter what direction we've got here because kinetic energy is just 1/2 mv squared. Even though our right cart is moving to the left and it has negative velocity, it is going to get squared, and that will become positive. Kinetic energy is always positive. It's just a magnitude of how much energy. To figure out our momentum, however, well, the momentum of our system is still the initial momentum of our left plus the initial momentum of our right, but now that momentum of our right cart is a negative value because it's a negative velocity. And so, yeah, you add these numbers together, but our momentum is negative for our right cart, so it's going to deduct from the momentum of the left cart, giving you a total momentum of the system. And those are the values that you should be getting for this particular setup of right faster with the 150 to 450 gram configuration. Now, you do the same process for after the collision takes place. And so here I've got my time 0 frame. This is after the collision takes place. And then here is 15 frames later. My right cart, as you can see, has only gone about 1 centimeter, whereas my left cart has gone about 6 centimeters. And so now you can see that the right cart is not moving as fast as the left cart, unlike it was before the collision took place. And that should make sense because overall we have more momentum for our system going this way. The right cart is going faster and it's got more mass. So for that right cart, its mass is bigger and its velocity is bigger. So for our system, overall, it's going to be a negative momentum. And you should see that in your calculations for the initial momentum of the system. Now, what else you should see, the initial momentum of the system should equal your final momentum of the system. So when you're doing this calculation again for after the collision takes place, your initial momentum and your final momentum should be pretty close to the same value. What will be different, slightly, for this situation, is how much kinetic energy your system has.